Okay, I think this is recording. We'll see. Okay. Yeah. Oh, that's good. Strong start. What's that? Oh, yeah. Wouldn't be the first time that's on record, though, let's be honest. Oh, yeah. Okay. Oh, it's too large there, too. Ooh. Yeah. Or I could put it on a USB, I guess. Sorry, guys, give me 2 seconds. Should have saw this coming because graphics in R can be really big. And that's actually something we'll talk about Wednesday, how to keep the memory down. Because if you have 62,000 points, if you're trying to plot them, each of those points takes up a lot of space. Okay. Okay, so what I've done here is I'll send out 2 emails. The first 30 slides are going to be in the first email. The second 30 slides are going to be in the second email. If you guys can just like merge the PDFs together, that'd be awesome. And I'll, like I said, I guess you didn't see my email, but I will make this smaller. There's a way you can change the resolution in R that's really convenient. Hopefully that goes through. Otherwise, we'll pass around a USB and be like super old school, I guess. Okay. Well, sorry, now my computer's revolting. I heard somebody's email just bing, hopefully. That was me. Did it go through? Okay. All right, so today we're going to talk about ggplot, which like of R is my second most favorite thing in the world. So I need to thank Mike and Sarah, of course, and then I've stolen a ton of things from Stack Overflow, Hadley, Garrett, Jenny Mine, and some of the other people who work for R. And all these contain links, so, or I guess they don't, but throughout the presentation, there will be links for the different like pages I stole from R for Data Scientists and Advanced R and things like that. They don't embed well in PDFs, but if you just hover over them, you should be able to see them. So today we're going to review the tidyverse, and we're just going to understand the basics of ggplot. And then on Wednesday, we're going to do what I call like advanced ggplot, and it's mostly going to be getting your pictures really customized and your figures like really beautiful, which I think is probably one of ours like most popular features or best features. And so Sarah showed this awesome slide last time, and so today we're going to, or this week, we'll focus on ggplot. But I just wanted to review these various packages since we just introduced the tidyverse. And so we're going to review dplyr, tibble, tidyr, and readr today. And then we'll come back to purr later. I know Mike shared that really nice bit of code there at the end where he was using a single like nested call there to model several different equations, things like that. So we're going to return to that at the end of the semester because that's a bit more of an advanced topic, but is a really powerful tool. So, yep, tidyverse and ggplot. And then this is the same structure as my previous lecture. The R code is going to be in gray boxes, and the output is going to be below it or next to it, usually by double hashtags. And so I just want to have a quick clarification point. That pipe function that Sarah introduced last week, it's not only for dplyr. You can use it for anything. The pipe is actually from this package called Magitre. I don't know, it's supposed to be pronounced with a sophisticated French accent, apparently, which I lack. But the pipe operator is simply, as Sarah said, it's a function. It's taking something on the left-hand side and putting it into the function that you have on the right-hand side and having an output. So I just wanted to clarify that that doesn't have to be a dplyr function. That could be any kind of function. Like for example, here I could say paste high and then make it uppercase, which I've done here, which are all base R functions. Yeah. Oh, and something that I do a lot, but some people don't. So you can see here there's two different syntaxes that are used. I've called the function here, and R knows to paste it or to pass it kind of in this place where I have the period. But that period's a placeholder, and for my own sanity, I like to put it there just so I know what R is piping into the function that I'm calling. This becomes more important when functions have multiple arguments. So paste only has one argument. It's going to paste whatever I tell it to. But let's say you had an apply function where you have a data, a row, and a function call. Then you might want to specify what you're piping into. And so you would put the period there under data or something along those lines. Does that make sense? You'll see this throughout my code. I use the period a lot just for, again, as a placeholder. It's just more explicit or obvious. Okay. So we've been talking a lot about tidy data. And this is one of the things that I am very, very passionate about and will be on a soapbox for a long time, but I'll spare you that. But what tidy means is that this is defined by Hadley, and there's a great paper that I link to later on if you want to explore more of this. But it means that each variable has its own column. That means for example, MAGE, maternal age, is its own column. And then each observation has its own row, and each value must have its own cell. And so most of you are like, this is really obvious. I expect my observations to each be a row and all my columns to be different variables that I care about in my data set. But a lot of times you'll be handed data that's not tidy. And like I said, this seems really obvious, but it can end up being really, really powerful to make sure that your data is tidy. And it's estimated that 80% of the time of any data analyst or data scientist time is spent actually taking data from an untidy format to a tidy format. So is our burst data set set up in a tidy format? I think you guys know that it is, yeah. So I just wanted everybody to go ahead and practice reading it in again, except now instead of using base R and that read.csv program, let's use the read R program, which is part of the tidyverse. And so you'll use read_CSV. And are you guys familiar with this read R : here? Yeah. Okay, so that's called namespaces. I really like using this in my code because I have the memory of a goldfish. So anytime you want to call a function, if I type read R : and I hit tab, it'll show me all the functions and all the things, all the environmental items that are in the read R package. So I often use that namespace argument that's double colon just to help me remember what functions are named and things like that. And so same thing for dplyr, mutate there, or something like that. So again, you'll see that throughout my code. I just wanted to clarify why I had that. And so go ahead and read this in and make sure you specify that column names are true. And you'll see here you have an underscore again instead of a column dot names. And then if somebody opens up burst, you actually paste it, you're going to see that it's going to say a tibble. And this is the post homework 2. So I have 62,370 observations. And I just subsetted it here to preterm, PNC 5, and MAGE, so it wouldn't overload the screen. But can anybody tell me what the big difference is between a data frame and a tibble? We're going to talk about it next, but are people familiar with this already? Okay, great. So I love tibbles, and I think Mike and Sarah would agree we're all tidyverse fanatics. But we introduced base R first because tidyverse and all these programs are actually built off of base R. And so the main difference between a tibble, which again, here we've made a tibble because the default from read R is to make a tibble, and a data frame is basically that this is straight from Hadley, who made the read R packages. Tibbles are data frames, but they just make life a lot better. They'll never like change strings as factors. They'll never convert anything that's a character to a factor. It'll always just keep characters as characters. So it's by default, strings as factors equals false. You can also have column names that don't usually work well in R. For example, if you start a column name or a variable with a number or like a weird @ sign or something like that, base R will be really angry with you over that, whereas tibbles and the tidyverse can handle that, so it can make it more convenient. Those are called non-syntactic names. And like the main differences are just the printing. So like as you saw before, if we would have called burst as a data frame, it would have just completely overloaded our screen. It would have printed out all 62,000 observations, or it would have tried. I think it only prints like the first 100 or maybe a couple hundred, and then it stops. But either way, it overloads your screen and you can't actually read it. And versus a tibble, these really nice properties that will only print the first couple of rows. I think 10 is by default. It tells you what the column name is, what type the column is. So it says here preterm is an int, PNC5 is an int, and mage is an int. So that's a numeric or an integer as the type. And then it also gives you the dimensions. So this would be the same as if we called dim on a data frame. It gives you the number of rows in the first and number of columns in the second. And so this is just a really nice way to be able to like interrogate your data on the fly without having to worry about just like blowing your screen up or anything like that. And then the other big thing is subsetting. Basically, like as we talked about, like data frames are actually a series of lists that are all the same length. And so tibbles kind of use that framework by calling this $sign here. But I think that if you're using tibbles, most people are going to be using the dplyr functions such as filter and select that Sarah covered. And so you do a lot less of the calling of like specific columns with the money sign or the double bracket here. Instead, you use these filter and select functions. But it can handle that. It just won't let you do partial matching and like some other more advanced stuff that people do when they're using like rejects and other like string type matching stuff. But tibbles won't let you do that. It's just very strict. It's very difficult to break, and that's on purpose to kind of make it easier to use. Okay, so what if your data isn't tidy? And I know that the burst data set, for example, here is tidy, but I wanted to give an example of my own like experiences of not dealing with tidy data. And so there's this great package called tidyr. And the two types of data that we talk about are either wide usually or long. And long data is typically tidy because each observation here, the IDs 1, 2, have its own row, and then each value or each variable, key and value here have their own columns. Versus a wide data frame has like the ID here with multiple repeat values. And so this can be really inconvenient because, I mean, X, Y, Z here aren't really the variable names that we want. We want the variable name, key, and value. And so to take that from like wide to a long format, we can use this the tidyr package. So I think Sarah showed these animations earlier last week, and I could honestly watch these like for days. But I really do encourage you though to go and review the joins, because those are really powerful, especially for understanding like what data is being subsetted out of your data frame whenever you do a merge. But to get back on track, what I was talking about is this tidyr package. There we go. And again, so long data format is tidy. Each variable has its own column and each observation has its own row. But if you want to go from long to wide or wide to long, you can use these tidyr spread or gather variables. And so we'll just watch what's going on here. So this is when it's wide, and we say we want to gather that data frame, which is named y. Well, that's going to be a problem. But you say, I want to gather this data frame by y. This is the variable I care about. These are the values I expect to be there. And that you'll see the x to z, those are the rows, or I'm sorry, those are the columns that I'm going to take from wide, and now I want to replace into long format. And then you can do the exact opposite with spread. So you could take a long data frame here and say, okay, spread out the key and value, doing, again, spread long key val. And so I have a specific, again, go back to those GIFs and just watch them for a little bit if you have a chance. I think they're really helpful for understanding what's going on. But for a real life example, so I work a lot with genomic data. And so typically genomic data is given in what's called a variant call file. And so each row here is a specific loci, which just means like a specific gene or a specific site that we care about. And it tells me like what the reference base is there, so either C, G, or A, and what the alternative base is. And then each individual, these are individuals' names here. A 0 or 1 is whether or not they have that gene, have that SNP, whatever. So this format is wide and is untidy, again, because instead of each individual having its own row, it's set up as SNPs. So to go from a VCF, which is in the wide format, to making it long and tidy, again, I can pipe VCF into tidyr_gather, data equals here, period. So it's taking the VCF into that place. My key that I want to take, like name this column that's going to be is ID for like individuals. And then the value, I know these values here are genotypes, which I've set GT. So for the record, I could name the key and the value anything I want. That's just saying, okay, this is the individuals or the observation variable, and this is like the value that should, like what was in wide format that now I want to make long. And this is kind of the most important specification. It's saying like which columns I want to take from wide and now kind of compress into long. So for me, it's column 5 through the end. So 1, 2, 3, 4, 5. I'm starting here. And I just used endcall, being lazy, to say take it all the way to the end. And so you can see here saying, okay, now spread that long VCF. And again, my key here, the things that I want to be columns is ID, and the values that are going to go in there are the genotype values. Does that make sense? Like spread versus long or gather? And the only reason I'm showing this is because ggplot prefers long data. So if you ever inherit a data set that's in wide format, you're most likely going to want to make it long. One, for just making your life like easier, keeping it tidy, but two, ggplot really doesn't handle wide data very well unless you're doing specific genomes that we'll talk about later. Okay, does anybody have any questions? We good? Okay.
I have a question.
Yeah.
If you go back to the last slide.
Yep. Oh, sorry. Yep. Here.
Where, yeah. Is it possible for the ID, for example, to be maybe in the middle and then specify the two different sides of that key variable?
What do you mean by in the middle?
So if when you were on slide 2, you were explaining how maybe you wanted all the variables on the left-hand side. And that's why you had 5 colon. But if it happens that you want some variables on one side, some variables on the other.
Sure. Yeah. So you're saying like, what if, for example, I wanted to keep 7G8 there, like there? Yeah, you definitely could. You can specify whatever you want for it to like gather, and it'll just copy like this row. For example, if I would have said, it didn't work for row, but it would have copied this row if I had said 7 to 9 here, and it just would have repeated this row for each of these 3 values as it makes it from long to wide. The incentive to not do that is like then you're mixing and matching a wide and a long data frame, which can get really confusing. The only reason I want to repeat these variables are the position and like the referent and alternative allele are fixed for each of these individuals. Like that's always the same. So I don't mind copying and pasting that value over and over again. What does change is whether or not they have that SNP, which is the 0, 1 for that gene. So that's the like logic behind going from wide to long. You want to make it so that each individual has kind of its own representation for that observation. Does that make sense? Yeah, thanks for that question. That's a great clarification point. Any others?
On slide 22, on slide 20 also, how do you know that it's not tidy? Is it because 6, 7, and 8 have the same?
Yeah, sorry. I just know because this is data I worked with. I made this data like for fun. But like I know because like it's saying this is what it would have said. Like if we were like more in like an epi world, it would have said like whatever, mage. Yeah, so like mage is a row, and I would have said like person 1, 2, 3 is 35, 40, 41. And so like this isn't tidy because what I really want is like mage, and then person 1, 2, 3, 35, 40, 41, right? And so this is kind of set up like my example of VCF here. Honestly, like I don't think most epidemiologists or most like people who do data analysis have wide data a lot. It just like I've inherited them from people like my bosses, for example, just like filling in an Excel sheet and kind of like not thinking about the like whatever, like long-term, it's just easier to fill it out wide than long. And so, yeah, it definitely, like to me, I was struggled to think of an example of a wide data frame because I was just like, it's so counterintuitive to me to have. But if you ever run into it, these are the tools. And to be honest, I have to Google spread and gather every time I use them. And I'm like, how do I do that again? So there's great documentation for it. Molly, did you have a question too? Okay. Okay. So now we're going to talk about ggplot. And I need to send out the second email, so give me 2 seconds. Yeah, sorry about this, guys. I should have saw that coming. Okay. Again, let me know if that has any trouble. Okay, so ggplot2 was written by Hadley Wickham, but it's actually based off of a philosophy of a book by Leland Wilson back in like the 80s, I think, called Grammar of Graphics. So that's what the GG stands for, is Grammar of Graphics. And so the goal is to have a consistent language around what you're doing. And this basically boils down to what I think about as a recipe. So every graph has a few key components. We have data, we have a way to represent the points, and we have a coordinate system. And so in Hadley's own words there, you can read that. I think about it as like a recipe, and then as we'll discuss, you basically just add layers onto this base plot of like XY coordinates, and you just keep layering your data on top of it. And so there's basically 5 main elements. Again, there's the data, this mapping aesthetics, and that's what we want to plot. The geom, which is the shape or the characteristics of our plots. There's a stat argument, which can be statistical transformations to do to the data. There's position, which can adjust the characteristics of the geom. And we're going to dig into each one of these elements. And again, so like just as an overview, this is the basic syntax call for a ggplot. So again, you have a data argument where you specify what data you actually want to plot. You have a genome function, which is how you want to represent your points. You have this mapping function, which is how you want to map the X and Y values or whatever values you want onto your coordinate system. And that's dealt with in aesthetics, which is another function within the ggplot. These things in dark green here are required. These are really important arguments, where the things in light green usually have sensible defaults for a specific genome. geom. We'll talk about stat and position today. And then on Wednesday, we'll go into different coordinate systems, faceting, which is amazing, scales, and then themes. And themes is where you can really make beautiful, beautiful pictures and like customize graphing outputs very specifically. Again, like ggplot just prefers the data to be in a long format. Okay, so the first thing we always do when we start with the graph is we call ggplot, and we tell it what data we want. So if I were to plot just ggplot, data equals burst, it's going to give me a blank graph. And that's what I think about as like maybe the plate of our cake. And like it's just a setup for saying, okay, you want me to make a graph. You haven't specified any other arguments or anything else that you want me to do, but I'm setting up this coordinate system in mind for whatever geom function or shape that you want to put on top of this. So again, this is kind of just the plate for our cake that we're going to make. We're going to layer data on each time. And by default, I mean, most geoms will have the coordinate system be a Cartesian system, which just means there's an origin. Usually it's going to be the minimum of the data or 0, 0, depending on how your data looks and things like that. So the next argument we add here is the aesthetics. And the aesthetic mappings describe how or which variables you want in the data to be mapped. And so aesthetics are mapped to visual properties of genomes. And so you can see here, when I specify ggplot data equals burst, aesthetics on my x-axis, I want mage, and my y-axis, I want each jest. And so it now knows that, okay, I have a plate, and I have a coordinate system, but you didn't tell me how or what shape or like what kind of data to actually put. So all it outputs here is a blank like graphing sheet of paper where it has the minimum of mage and the minimum of each jest. And it's waiting for us to add a geom, which are these layers that add the specific points or like properties of the graph. And so the easiest one from here is the end of my slides. Did the second email go through, guys?
Yes.
Okay, great. Sorry for the struggle this morning. Okay, so the next thing to do would be to add a geom. And so here I've added geom point, and now R has plotted for me all the points in my data frame. For each jest on the y-axis, on the x-axis is mage. And so it knows that I've applied these aesthetics where on the x-axis, again, I want mage, y-axis, I want weak jest. The data is the burst, and then I've specified which genome I want, and here it's geom point. And so it's literally placed a dot for each observation in the data set. Now, can anybody tell me why I don't have 62,000 points here? Since my data frame contains 62,000 observations or 60,370.
Yeah, there's a lot of overlap.
Yeah, exactly. So this is why or where the position arguments actually come in handy. What the position arguments are doing are altering the defaults of the geom. So in the defaults for geom points, it says like stat equals identity, which we're going to talk about again, and position equals identity, which just means put the point exactly where you said. Like you said, mage was 30 and weak chest was 28. I'll keep putting points at that spot no matter what, even though there's 100 people at that have those specific characteristics. And so a way to get around that will be to use this position argument, which we're going to talk about again. And you can use jitter, which again I show here. And so this, for example, what jitter is doing is it's saying, okay, move my data point, like offset it by some like random number. I forget exactly what the defaults are, but it'll just basically try to dodge the point. So that gives you an idea of what the data represents. So on the left-hand side here, you have geom point, which again, position is identity and stat is identity. So it's just plotting that point exactly where it wants. And here I've done geom jitter, where the position is now jitter instead of identity. And again, points are kind of just getting spread out a little bit so that you can actually see where all those 62,000 points actually land, or give you a better sense, I should say. Yeah. So I will also note that like I could have said geom point and then I could have made a position argument here like this. Could have said something along these lines. I could have said this instead of doing geom jitter. I personally just find it easier to use the geoms that I've already built into R, but you can play around with these different things. But just be aware that each geom does have defaults, and if you ever want to open up what its defaults is, you can always do our question mark and the function name, right? So you can dig through the description, and it'll tell you like position equals identity is the default here. So everybody understand the distinction between like geom point and geom jitter? Good. So there are like thousands, maybe thousands is an exaggeration, but hundreds of geoms. This cheat sheet here is what come in base ggplot. There are like, and we're gonna go over a lot of these Wednesdays, continual package development for ggplots. And so there's a ton of geoms that you can do. I encourage you guys just to open up this cheat sheet, and this should be a link. Nope. If you just Google ggplot cheat sheet, see all the various geoms that you can do, and it has them separated by 1 variable, 2 variables, whether or not you want 3 variables, and then this is all stuff we're going to talk about on Wednesday mostly. But yeah, I just encourage you to like play around with the data and look at all the different geoms. And if you ever need inspiration for like different plotting or different figures, the New York Times has an amazing like data visualization like website. Or if you just Google R data viz, V-I-Z, there's also some just beautiful graphics there to inspire you of like how you could shape your data. Okay, so these are the 10 most popular used geoms: point, line, bar, histogram, regression, which is geom smooth, box plots, text, which you can add text for each of your data points. We're going to talk about this Wednesday too, but there's geom, text, and repel, so that it actually, R has built-in functions to offset the text points so they don't overlap, and they're made a lot easier to read, which is really beautiful. Adding horizontal or vertical lines here with geom V line or geom H line, a count or a density. So those are the 10 most popular geoms. Does everybody feel comfortable with geoms? Does that make sense what it's actually doing? Okay. And this, I think, is probably one of the most powerful like take-home points about R, is that ggplot objects are what we call like appendable. So if you look at my code here, I have bursts, I've piped it into a group by mage, I've summarized the mean week gestation for each of the maternal ages. I've then called ggplot, where I'm saying data is period, which is taking in this these 3 lines of code. On the x-axis, I want maternal age, and y-axis, I want this newly created variable here, mean weeks gest. And I'm calling geom point, so it's plotting the geom points first, and then I'm calling geom line. And so it's literally, again, if we stick with our cake analogy, we built the plate here with the ggplot call, and now we've added the geom points as our first layer, and geom line as our second layer on our cake. And so I've specified the geom line color here as red, and you can see how it's literally sitting on top of the geom points. I just want to emphasize that. And we're going to talk about labeling and things here. But just briefly, since they're already here. So to label your x-axis, you can do this a couple different ways. I like to do xlab, ylab, and then ggtitle. You can also open up ggplot labs here, and you could have just said x equals, y equals, title equals, subtitle equals, caption equals in one call instead of having these 3 different functions. Those can be used interchangeably. So what I mean by that is like, I could have done this instead. X equals maternal age, what type today? Y equals mean whatever it was, right? Those are the 2 options. Or you can just simply, I like to call the different functions again, just because that's how I think about it. But xlab and ylab will paste it here. You can add subtitles, which will add it right beneath the subtitle or the title. And then captions will go on the bottom of the graph by default. On Wednesday, when we talk about themes, we can move these titles or captions anywhere we want in our graph. We can change what type of text, whether it's bold, italics, et cetera, et cetera. So we're going to open all that up on Wednesday and dig into that in themes. But this is how you kind of get the base graph going. And I think of like the labels as icing on top of our different layers of our cake. And so I just wanted to emphasize again, the only thing I've changed here is which order I've called the geomes. And so you can see because I've called geome line first, it goes beneath the points. And again, this is just to emphasize that ggplot objects are appendable. They're literally just layering on top of each other. Ours making a different graph at each point, just literally stacking them on top of each other. Does that make sense? Okay. Yes.
Can you explain again where it says data equals period?
Data equals period. Yeah. So that's a placeholder for what I've done in these pipes here, like this first function here. Like instead of defining these three things and making a new data frame, like I could have said mean weeks jest is my new data frame, then said data equals mean weeks jest, right? Instead, I've just told R, like what I've done in these first three lines, put here. And that's what that period is. It's a placeholder. By default, R would have like figured out that I wanted these like piping things to go into the data argument. I just like to be really explicit to like protect myself and to like make sure R doesn't do something I don't want it to do. Like by default, it will try to do what it thinks like you want it to do, which like data frame should go in the data argument. So it'll kind of know that by default. But anyways, it's just a placeholder. But I highly encourage use of them because it is good to be explicit in your code. Okay. So kind of building off that point, if you are going to layer data frames, for example, that maybe have two different data frames from two different sources, here instead of calling data equals period as we just talked about, which is those three lines I've made here, you can always add different data arguments from different data frames. So here I've made my megs, weeks, jest new data frame by these functions here. And then I've called ggplot here with, okay, I want all the points for births and mage and week jest. And then on top of that, I want this summary thing that I just made. So if I would have let it plot, I didn't because of size, but it would have pasted the 62,000 observations and then these data points that are on top of it. So you can layer not only different geomes on top of each other, but you can layer different data frames on top of each other in ggplot, which is really, really powerful. Does that make sense? Okay. So now we're going to dig into each of the topics. And so we'll start with aesthetics. And so an aesthetic is a visual property of the objects in your plots. This is straight from Hadley. I steal everything from Hadley because I just think the person who wrote it should have the last say on the functions. But so the aesthetics include things like size, the shape, or the color. And so far, we've really only been thinking about aesthetics as x and y variables, like we would plot on our Cartesian graph. But what if we wanted to add additional like features to our x and y points here, like color, size, to differentiate them by different classes, for example? And so here, I've done geome point, data equals births, color inside of aesthetics equals preterm, and I've kept it here with the factor so that my label here will output a preterm and term instead of a 0 or 1. And this is a great way to check that you've actually coded your data correctly. Like we specified that preterm was 37 weeks or less. And so you can see here that there's a clear division in our data of where that happens. And so we've said, okay, within our aesthetics, I want you to add a third variable here that is color to map on top of the x and y, mage and weeks jest. Does that make sense? I think this is like really powerful. Okay. So a common, and you can do the same thing with shapes as well. So color here is preterm, shape here is preterm as well. So now you can see term is blue, which red and blue are the first two default colors that ARC will give you. Again, Wednesday we'll talk about using scales to change the colors, but here I've said, okay, give me a different color for each of the classes of preterm, which there's two, term or preterm, and also change the shape. And so you can see in this plot, there's red circles and blue triangles instead. Cool. You can also do this with size, and this is really powerful if you have varying observations. So if you know that you're doing like a summary, but there's 100 observations in one class or whatever, there's 100 observations for maternal age of 35, but there's only one observations of a woman that's 55 that gave birth, was I think is true. You could have used that to kind of show how the data is built. So size is another aesthetic. And again, all the aesthetics are going here in the legends by default. And the last aesthetic that we use a lot is this alpha term, which is just the level of transparency. So by default, R sets it to 0.5, except to like when I layer things to make one layer more transparent so you can see beneath it. Did you have a question?
Yeah, when you're changing the colors and the shapes,
Mm-hmm.
does the variable have to be a factor?
No. Yeah, thank you for that clarification point. It can be whatever you want. I just made it a factor. I think I said something about it. Anyways, I just made a factor so that the legend would come out preterm and term, so it's easier to see. But it could be a character, it could be an integer. R, like for example, if I would have said, if preterm were a continuous variable, it would then kind of plot it as like a continuous spectrum of blue is like the default. So it would have started light blue as like, let's pretend preterm range from 0 to 100. So light blue would have been 0 and 100 would have been dark blue. And it'll give you that gradient throughout. Yeah, so they can be any kind of variable. Great question, thank you. Any others? Okay. So I think this is really important. So you may have noticed that I use color inside and outside of the aesthetic argument, depending on where we were. The geom line, I used color outside of the aesthetic argument. And this is a huge important distinction because when we put aesthetic inside or color inside of aesthetic, we're saying I have a third variable other than X and Y that I want you to do something by. I want you to affect this class. This is a new variable. Whereas, so R interprets this as you want me to change the color, the shape, the alpha, the size, whatever, dependent on this covariate. This is different than if we had color outside of the aesthetic argument. That's just if we were assigning a specific property to the entire geom object. So I see this as an error a lot, like people put, I think I do this down here, yeah. So like people do this on accident all the time, myself included. Like you're going along and inside aesthetic, you say color equals blue. And R is like, okay, I think they do, but there is no blue like column, there is no blue covariate. So R just is like, okay, I'll just put everything to red. Versus if I put color equals blue outside of the aesthetic argument, it knows that I want to assign blue to all the geom points in this plot. Does that distinction make sense? I do this all the time on accident, and I'm like, why did I do that? All right. So the next point of differentiation is within aesthetics, there are fill and color options, and depending on the geom, fill can either mean like the inside or the border. Geom point only has one. It doesn't allow you to mess with that. You can get fancy in the themes and things like that. But anyway, so like fill typically for bar plots just means like the inside, and color typically refers to border if that geom allows you to have both a fill and a color. Okay. So now we're just going to dig into the position arguments. And I think this is more specific for bar graphs than anything else. Geom jitter is the only other time I use it in geom points. But bar graphs have a few nuances that we'll talk about. And so here I have data equals burst. On my x-axis, I have the factor race and ethnicity that we made. And I've said fill equals preterm. And so it's filling this count up, whether or not the birth was preterm or term, by the race here. And so you can see by default, it just stacks the counts, or just layers counts, and then colors in how much of those counts are attributed to each of the classes. And that's the position equals identity or position equals fill that I'll show in a second. If you do position equals dodge, it'll separate them and place them side by side, so you have a side-by-side bar graph. Again, so default is position equals identity. And then if you do position equals fill here, it'll actually change it to a proportion. And so it tells you how much of each of those bursts were preterm or term, like the percentage. This is actually when I specify position equals fill. We're going to talk about this in a minute. It's doing a statistical transformation. I personally, and I think Mike and Sarah agree, recommend doing all these statistical transformations in dplyr upstream of your data and then plotting it like as identity. And the reason for that is you're going to kind of want to know what your percentages are at the end of the day. And if you just plot it like this, ggplot doesn't have that data. Like I can't say for certain this is within African American, preterm is 18%, 17%, 20%. I can't really tell by digging into that. Versus if I had done this, like, okay, make a percentage by race ethnicity upstream, I could then print that out and like publish that or whatever, put that in a table somewhere. But R will do these statistical transformations for you.
Where is that table?
Oh yeah, so we'll talk about this on Wednesday as part of theme. Basically though, as a teaser, I've said on the x-axis, the text of the x-axis, I want the labels to read at 90 degrees. And that's just because I couldn't fit those horizontally, otherwise they would have all overlapped. Okay, so again, like statistical transformations are a more nuanced topic. Most genomes will have stat equals identity, meaning they won't do any statistical transformation on your data. They'll just plot your data as is. So one of the things, though, that a lot of people do is if you have a bar plot, instead of plotting counts, they want to plot proportions. And so this can actually be done with this prop argument. And those two dots that surround the plot actually are telling ggplot, I want you to do the statistical transformation like from count to proportion. And it's calling this stat prop argument that I'll show you in a second. I really prefer making all this upstream, but just to show you that you can do this on the fly. So these are all the different statistical transformations that R or ggplot can do. There's 22 in total. Again, I don't use these a lot in my everyday coding, except for maybe stat smooth, which we'll talk about more when we do modeling. So you can see here, I've done on the x-axis is weak num. On the y-axis, I've now specified that I want R to do the statistical transformation of changing this count to a proportion. And then I've just plotted as a genome bar here. And so all this prop is doing is somewhere in here is a stat proportion transformation. It's just doing that on the fly for me. And this is essentially the same plot as you would get if you just plotted the counts, right? Use proportion versus count. Prop and count as part of my theme. So for the rest of the day, I'm just going to briefly touch on labels. We've already mentioned them a little bit. And on Wednesday, we're going to dig into scales, which is how you adjust the shape and the colors and the different aspects of your genomes. Faceting, which is how you can have like several subplots on the same plot, as well as different coordinate systems to kind of set us up for maps later on. And then themes to like really modify and customize your plot. So just briefly, I went over this already. And here, again, I'm just making this summary plot, but I've specified here that I want my title, my subtitle, the caption, and X and Y, as I mentioned earlier, instead of doing XLab, YLab, and ggtitle. And that's just pasting these characters here. Yep, and this is an equivalent approach. Again, I could have just done XLab, YLab, ggtitle, and those things. Whatever is easier for you. Okay, so this is for your homework 3, question 2. And I think one of the question is based on maternal age, count the mean mothers who had early prenatal care, and then count the number of preterm births. And you layer those two things on top of each other. And this got cut off. But as you can see here, like what I've done, because we have the number of counts here is n. So here I've piped, like I've made a new data frame, made df, and I've grouped by maternal age. I've summarized n equals n, which is going to give me the counts for each of the maternal ages, how many observations there are. And then I've taken the mean here of whether or not at that maternal age prenatal care was given, which is the proportion of prenatal care. And then here, the proportion of preterm births, again, by maternal age. And if we were to open up that new data frame, which is actually a tibble, you can see here that it's just mage is an int, n is an int, and then we have doubles here as the proportions. And so if we were to plot this, I can say by default, R assumes the first argument here is x, the second argument is y for the record. Again, I usually try to be more explicit in my code, x equals, y equals. And I've said here, okay, plot genome point, but I want size, which is, remember, another aesthetic, to equal n. And so now my points will be weighted by the number of observations that are at each maternal age. And then I'm adding geom smooth, which is a regression. Again, the weight of that regression is weighted by the number of observations. And it's blue, and I've done here just a low S, which you guys will cover in your biostats class, but it's just locally trying to maximize like all the points by the weights. It's just a local scatter regression model. And then here I've just added the labels again. So if you guys want to run that code on your own and just look at this output, you can play around with it. You can kind of see like color here, blue on the outside, should specify that blue is low S because that's the method I've called here. So geom smooth is really an amazing function. We use it all the time, especially when we're modeling regression models. So I encourage you to go ahead and open it up and read it. And that is everything I have today. But as a call forward, yeah, the graphs we made today were pretty. But on Wednesday, we're going to be focusing on making graphs like really, really pretty. And I think this is the power of R. You can also make graphs interactive with this Plotly library. So you can actually hover over points and it'll tell you like, okay, at this point, the maternal age is 35 and the week's just was 29 and things like that. So anyways, this call forward, we'll cover all that on Wednesday. But are there any questions, comments, or anything like that? Okay. If there's no questions, I'll hang out after class if anybody like wants to catch me or anything like that. Otherwise, I'll let you out a little early and have a good Monday. And sorry again for the confusion. Like I said, I just got back this morning and I may or may not have been a little tardy in submitting them.